Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.1, Problem 5. This is Section 15.1, it's problem number 5. We want to find the integral of x squared plus 5x plus 9. So, the x squared here, let's assume it's a 1x squared, so it's going to be 1 over 2 plus 1 x to the 2 plus 1. Again, the 2 is my exponent here. The 5x, the next piece in the middle, let's assume it's a 5x to the first. It's going to be what gets to go plus 1. So it'll be 5 over 1 plus 1, x to the 1 plus 1. And then the 9 at the end, you can assume that's coming from a 9x to the 0. So it'll be 9 over 0 plus 1, x to the 0 plus 1. And when you do an integral, there's always a plus c at the end that could have come from some constant. C is for constant, a number with no variable, like say 4. So we can simplify this. The 1 over 2 plus 1 will be 1 over 3, and the x is x to the 2 plus 1, or x cubed. Now the next piece, I have 5 over 1 plus 1. That'll be 5 over 2, x to the 1 plus 1, so x to the 2. And then 9 over 0 plus 1 will be 9 over 1, x to the 0 plus 1, so x to the first, plus a constant. And most of it doesn't really clean up that well. The 1/3 x cubed, is this really going to stay 1/3 x cubed? You could call it x cubed over 3, but I'll leave 1/3 x cubed. The next piece, 5 halves x squared, will also stay 5 halves x squared. Again, it could be written 5x squared over 2, which is the same, but I like 5 halves x squared a little better. The 9 over 1x to the first, that does clean up pretty nice. We can just call that 9x. And then you have the constant. That's the answer. And you can check to verify this. Let's take the derivative of what we claim the answer is, and it'll give you back the original question. So the first piece of our answer, 1/3 x cubed, if I bring the 3 as the exponent down times the 1/3 in front, 3 times 1/3 cancels, and I have a 1 in front, x to 1 less power, it is x squared. The next piece, 5 halves x squared, let's take the derivative of that. The 2 comes down times the number in front, 5 over 2. The 2's cancel, giving me a 5x to 1 less power. That second power drops to a first power. And then the 9x has a derivative of just 9. And the constant, or plain old number, would just go away when you take the derivative. So again, the answer must be correct.